Yes, please check if screen is visible to you or not.
Yes, sir.
So here one network is given and we need to verify whether reciprocity is applicable or not. So the statement of the example is verify the reciprocity theorem for the given network. So I'm drawing the that network. This two loop network is given. Now I'm drawing the elements. One supply available over here. This side are the resistors, passive elements. So 20 volt DC source. This is independent voltage source. This side one resistor, that value is 5 ohm. This side one more resistor, that value is 4 ohm. Here is also one more resistor, and also this side is also one more resistor. This value is 10 ohm and this is 6 ohm resistor. Now for this network we need to verify the reciprocity theorem. So we all aware that like this is what our input side. Suppose this we are consider as our input side and this we are considering as an output side. So we can say that suppose some current will flow through this way. Suppose if I say that current is I. Suppose if I interchange this one. Suppose if I connect this 20 volt source to this side and if I short circuit that one, this current should flow in this branch. So before that we need to find the value of I in this one. Before that we need to find the value of I in this one. How to find the value of I? Can anybody tell me? Find the value of I first.
V equal to IR form.
Yes. You can apply that, like suppose you go like this way. Suppose if you say this is I1 and this is I1 and this is I2, likewise you can go. If you do not want to simplify the network and if you do not want to apply the other concept, this is very simple. The node analysis or mesh analysis we can apply. So let us apply the mesh analysis, then I2 will be equal to I in this case. So tell me equation of KVL for mesh 1. It will be
20 minus 5I1
minus 5I1, then minus
10 I1 minus I2.
I1 minus I2, correct, equal to 0. When you simplify this one, you will get 20 minus 5I1 minus 10I1 plus 10I2 equal to 0. When you simplify this one, you will get minus 15I1 plus 10I2 equal to minus 20. So this will be our first equation. Now you go in loop 2. So KVL for mesh 2. So when you apply KVL for mesh 2, please quickly tell me the equation. Waiting for the equation.
Minus 4I2.
Minus 4I2, correct?
Minus 6I2.
Minus 6I2.
Minus 10I2 minus I1.
Minus 10. I2
I2
minus 1.
minus I1, correct. Now just simplify this one. It will be minus, this is minus 4 minus 6, that is minus 10, and then minus 20. And over here you say this is plus 10 I1 and minus 20 I2 equal to 0. This is going to be equation number 2. Now solve this one. Find the value of I1 and I2 from equation number 1 and 2. Solve 1 and 2. Please tell me the answer quickly. What you are getting I1?
I1 2 amp.
2 ampere.
I2, yes, sir.
Okay.
I2 equal to 1 ampere.
1 ampere. Okay. So in our case, if you see the circuit, in our case, what you are getting? I2 equal to nothing but I, and that, sorry, it is equal to nothing but I, and that value is nothing but 1 ampere. Okay, that we have derived. Now we will going to do some interchange, that as per the reciprocity theorem, because we need to verify the reciprocity for this one. What we will do, we are going to do some changes in this circuit. We'll put this one, we'll put this source in this side, and this current will flow through this way. So I'm just going to make that changes. So this I need to remove, and I am just going to connect that one over here. I am not going to change this one. Okay, I'm not going to put this one this side. Only I'm changing this source. I'm changing this source in this side. So what I can draw over here, that is nothing but plus minus. I'm not changing the polarities even. So that is 20 volt this side, and this is going to short circuited, and the current flowing through this one. Suppose if I say the current is, now I say current is I dash. So actually I should be equal to I dash. Then I can say that this network is following the reciprocity. Now the same method, all of you aware that which method you are going to apply. We got our second network. We have interchanged the value. We have interchanged the supply, input and output side. Now we solve once again this one, this network. Find the value of I dash for the given network. So in this one, this was changed. Now you can apply like this way also, like you are applying the same loop analysis. You say this is, suppose you say this one is I1 dash and this is I2 dash. So over here you see the direction of I dash and I1 dash, both are reverse. So you can say like this way, I1 dash is equal to minus I dash. Am I right?
Yes, sir.
Because we are just assuming clockwise direction always, so I'm just written this. You can assume anti-clockwise as well. So if you assume the anti-clockwise, you can directly say I1 dash equal to I dash. You cannot take that minus. Okay, so let us take this one and apply KVL in mesh 1. Just tell me the equation. Minus, over here you apply, start from here. Tell me the equation of KVL.
minus 5 I1
Phi
dash
I1 dash
minus
minus
10
10
I1 dash
I1 dash
minus
minus
I2
I2
dash.
dash minus 10 I1 dash minus I2 dash
I1 dash minus I2 dash. Correct. That is equal to 0.
I2
So
dash.
we just simplify this one. You say minus 15 I1 dash plus 10 I2 dash equal to 0. So you take this equation number 3. Now apply KVL in mesh 2. Tell me the equation for the mesh 2.
Minus 4 I2 dash
Minus 4 I2 dash, correct?
minus 20 volt
Minus 20, okay.
minus 6 I dash
Minus 6 I2 dash,
I dash and minus 10 I2
10
dash minus I1 dash.
I2 dash minus I1 dash, correct. Now you just simplify this one also. So what we will get? You see over here it is minus 10 and it is go inside, then it will be plus 10 I1 dash plus 10 I1 dash. Then after if you work for the I2 dash, it will minus 4, minus 6 and minus 10. So it will be minus 20 I2 dash equal to this minus 20 go this side. So you'll say 20 and that is equation number 4. Now you solve equation 3 and 4. Solve equation 3 and 4. You will get I1 dash equal to something and I2 dash equal to something. What you are getting? Solve this both the equation and tell me the answer.
So I1 dash 5 ampere and I2 dash 1.5 ampere.
I1 dash 5 ampere. Please verify. Other students, please verify the same.
Sir, minus 1 ampere.
I1 dash
Minus 1 ampere, sir.
minus 1
ampere.
ampere.
Yes, sir.
I2 dash what you are getting I2 dash?
So minus 1.5.
Hmm?
Minus 1.5. Minus 1.5 amperes, sir.
Minus
1.5 amperes.
1.5 ampere. Please check other student. If you are getting the same answer, please tell me. How many of you are
Yes,
getting
sir.
the same answer?
Yes.
Same answer.
So you can say that as we have written over here, this I dash I1 dash equal to minus I dash. So we can say that our we are interested in this I dash. So we put this minus into minus 1. So we can say in our case I dash equal to 1 ampere. So this value is 1 ampere. So you can directly say as per reciprocity, if it is following the reciprocity, we say that I equal to I dash. Both the side we are getting 1 ampere. Okay. So we are getting the value, we get I equal to I dash. That shows that this network is following the reciprocity theorem. Okay, yeah, anyone having any doubt in this? This network is following the reciprocity theorem. Any doubt in this one? Okay, we will do one more example. I'm just going to show you and will highlight the necessary steps. The title of the example is same. Verify the reciprocity theorem for the given network. Verify the reciprocity theorem for the given network. And draw the network. Here 3 loop network is given. So 3 mesh available. Join those elements. So one source is available that we need to interchange. This is plus minus 20 volt source is there. This is a register. It's an independent source, and the registers, the remaining are registers only. So the value of all the resistor over here, this side is 2 ohm, this is 2 ohm, this is 2 ohm, this is 2 ohm. This one is only another value 3 ohm. Suppose this network across these two terminals, this is input side A and B terminals, and this is output side C and D terminals. The current flowing through this way, suppose that is I. Now we need to verify the reciprocity theorem for this given network. How will you check it? Can anybody tell me how will you check this? What will be the first step to solve this?
Find I.
First,
IPL.
find the value of I. You can use mesh analysis, loop analysis, nodal analysis, whatever you wish, but you find the value of I first. Then interchange the input and output of branch AB and CD. Okay. So after interchanging, if I draw a interchange branch, whole network, then the network will be look alike. Same network, but just I am changing the source particular branch. So this side will be short circuited to the other part. This all the elements will remain same. This side source will be added. This is a 2 ohm. This is 3 ohm. This is 2 ohm. This is 2 ohm. This side, this 20 volt source, and this is 2 ohm once again. So current from this branch, that will be I dash. So if find I dash for this network, and if I equal to I dash, then we can say this network is reciprocal network. Okay, so you can apply the concept of loop analysis. You find the value of I and you find the value of I dash. Both, if you are getting both the I dash and I, both the value of current equal, after interchanging, you can definitely say this network is a reciprocal network. Okay, yes, anyone having any doubt in this? So this part I am just giving you in homework, for your homework. Solve this at your home and just tell me that whether you are getting this network reciprocal or not. Okay, students, any doubt? If you are having any doubt in how to solve this, just let me know. So A, B, and this A and B. Anyone having any doubt in this one?
No, sir.
No, sir.
Okay. So I'm just stopping over here for as far as these examples and all concerned. I just already told you that we'll work on one quiz. I'm just going to take one quiz. So you be ready with the Kahoot quiz. I'm just going to share the screen once again, and over there you will have that pin code to enter the Kahoot. And in that